Welcome to your first video of the summer. I hope you guys are ready to rock and roll. I'm pretty excited about this. I'm especially excited because I don't know, what school or what teacher you came from in 5th and 6th grade, maybe even 7th grade. But my goal is to get you where I think you need to be before you get to high school. And you're going to see some stuff that's review from like today's lesson's probably more like 6th grade. But then you're going to see stuff that's all the way through 8th grade this summer, and it'll be a nice little preview of what I consider the most important things for your age. So let's get started. Today, we're going to talk about number sense, okay? And meaning that, like, how do you move around the number line? What kinds of numbers are out there, and how do you make sense of them? And this is really important stuff. This is kind of the foundation of, like, everything, right? So, what I want you guys to know is, oops, I messed up. There we go. Okay. What I'm kind of wanting you to know here is that, you've got 0, right, which centers everything on the number line, which is what this is called. I just let mine go from -5 to 5, but this thing keeps going for forever, and you probably know how far out it goes. It goes out to a number or an idea that's called infinity, and on the other side it does the same thing, except over here we call that -1. Negative infinity. And just so we're clear, this is where you spend most of your life until you're about 11 or 12. You're in the positive numbers over here. And once you get past 0 or behind 0, these numbers over here are called the negative numbers, okay? Now, if this is confusing to you, I think of it in terms of right and left. If I'm moving to the right, this is in a positive manner. This is the way we're used to going. And if we go backwards or to the left, those are my negative numbers. Some people also think of this as, up and down, like an elevator. Like, if you start on the ground and you ride your elevator up a few floors, you're really going this way. And then if you're riding down floors, you're going in the negative direction. So like if you wanted to go to the basement, you'd be over here. So I'm not sure if that makes complete sense, but hopefully it will as we keep going, okay? So what we're going to work on is fitting numbers on our number line, okay? And so to do that, let's just erase this here. To do that, let me erase that too. Hold on just a second. Okay. I want to scroll up and then let's start talking about different types of numbers. These are your categories: rational numbers, irrational numbers, and then we're going to talk about approximating radicals, okay? Now, a rational number, okay, is any number that can be written as a fraction. Can be written as a fraction, okay? Now, this is going to include whole numbers or something called integers. Integers are what you see here: integer, integer, integer. All of these are integers. They're also called whole numbers. And these are also included because any whole number can be written as a fraction. You may remember from the past, like the number 3, that can be written as a fraction because I can just stick it over 1. You know what I'm saying? So that's perfectly fine. It can be an ugly fraction. It can be like 111 over 25. Okay, well, that is an ugly fraction, but it's still a fraction, so it's technically a rational number. And even some decimals are rational numbers, because if I put like 0.25, you may remember that, a decimal is just a percentage of something, and so it can be written as a fraction. And I don't know if you remember, but 0.25 is like a quarter, so it could be written as a fourth. So these are all rational. Yay! Now, irrational numbers are going to be funky, weird decimals that can't be written as a fraction. So like, for instance, you may have something like 0.12561256, and that just keeps going over and over and over and over. That is an irrational number. It can't be written as a decimal. Okay. Another type of number that's probably the most famous number that exists is the number pi. And now a lot of you have seen this number pi and you know that it's a nerdy math thing. but you don't know like what it is. Well, if you type it in on the calculator, it's 3.1415, and then I think it's like a 926. I don't know it very far out, but it's a decimal that never ends. It keeps going and going and going for forever, and it therefore is an irrational number, okay? Another famous irrational number is the number e. You're going to do a lot with the number e. This is approximately 2.718, I think, and it keeps going. But you'll do a lot with that when you're like in maybe the 10th grade, okay? So don't panic on the e. You won't see it for a while. And other irrational numbers are square roots. Let me just try to put it in perspective. Okay, the square root of 11. Now, some of you may not even understand what a square root symbol is, okay? But when you see this symbol, it's asking you what number times itself is equal to the number underneath. So, for instance, something like the square root of 16, that is a rational number because can you think of a number that you multiply it by itself and it equals 16? Well, it's not 2 times 2 because that's 4. 3 times 3 is 9, but what's 4 times 4? 4 times 4 is 16. So when you see this little roof thingy, some people call it a roof or a radical, but it's a square root. And when you see that, it's saying what number times itself equals 16? Well, 4 is the magic number here. But with 11, like what number is that? Like what number times itself equals 11? Well, I don't know. I would have to pull out a calculator. And when I take out that calculator, it's going to give me something like a 3 point, I'm going to guess, I don't have a calculator with me, but it's going to be like 3.2 something something something. But anyways, it's going to be a really weird decimal number that can't be written as a fraction, okay? So now that we've mentioned radicals, we're going to talk about approximating radicals or square roots. So what that means is I really want you to be able to think of all of your numbers in the number system. Let's write them down, things that when you multiply it by themselves, what do they equal, you know? So like 1 times 1 is 1, right? And notice I'm using a little dot for multiplication. I know some of your teachers use an X for multiply. I just don't like that at all, okay? So either write it as 1 with a little dot 1, or you could write it in parentheses. That would be fine too. 1 times 1 equals 1. But I'm going to do the dot. 2 times 2 is 4. 3 times 3 is 9. So this should be easy peasy for everybody. And let's just do to 6 because we're running out of room. Okay, so the point of this is so that if somebody gives you a radical or a square root and they're like, hey, what's the square root of 25? This is like working backwards from what we did here. So that would mean, well, 25 is asking what number times itself equals 25. Well, we just did that, right? The answer would be 5. But if somebody gave you like the square root of 30, and 30 is not on our list right here, right? What you would look for is the fact that 30 is in between these two numbers, right? 30 is in between 25 and 36, which means the answer to this is going to be somewhere between these two numbers over here. So it's somewhere between 5 and 6. So it's like 5 point something. Now, the way you decide on the point something is I always look at, is 30 closer to the 5? The one that goes with 5, or is 30 closer to the one that goes with 6? Well, 30 is a little bit closer to the one that goes with 5, but it's pretty much right in between. So I would probably call it a 5.5 because 5 is right there in the middle between 1, 2, 3, 4, 5, 6, 7, 8, 9. So you kind of can guess like that. So if somebody said, okay, I want you to put the square root of 30 on the number line, well, I would just have to say, well, that's about 5.5, and then I would come out here, and right here I could put a dot right up here. Not like that. Let's try that again. Just a second, peeps. There it is. Okay, I could take this, and then right up here I could label like square root of 30 could go right there, okay, on the number line. So that's kind of how it works. Okay, so fun, right? I know you're having a great time with that. Okay, so now that we've talked about different types of numbers, we're going to talk about integers and fractions, and it says here like just the basics. So the idea would be, you know, how do I say this? The idea would be, how do I place numbers in the right spot on the number line? That's going to be the number one thing. Well, if it's a whole number, guys, it's super easy. It's almost like dumb to talk about. But if I was like, hey, where is -3? You'd be like, duh, it's right here, lady. Okay, so those are easy if it's a whole number. And then some of you are pretty good with fractions, you know, and some fractions are easier than others. So if you were asked to do like 1/2, right? Well, 1/2, in fact, let me change colors for this. Okay, 1/2 is somewhere between 0 and 1, and in fact, it's halfway between, so you could put it right there, okay? But some fractions might be a little trickier, right? Like, what if I asked you to do like 11/4? Okay, well, 11/4 is an improper fraction, so you would have to approximate that, and you'd have to say, okay, well, 4 goes into 11 twice, okay, with the remainder of 3. So this is the same thing as 2 3/4. So when you go to put it on the number line, you'd have to go over 1, 2, and then 3/4 of the way. So maybe like right here. This is not an exact science. This is just a guess, kind of a approximation. And that's where you could put that number. And hopefully you remember how to turn an improper fraction into a mixed number. You just divide, and then the remainder goes on top, okay? Now, what if I did another one of those square root ones, okay? So let's do like a negative, let me do a negative out here, square root of 10. Okay, so first of all, the negative lets you know you best be somewhere over here, okay? And then the fact that it's the square root of 10, you're like, what number times itself is equal to 10, okay? Well, if you look at your list, we wrote down that 3 times 3 equals 9, and then 4 times 4 equals 16. So since 10 is between these two, then my answer is going to be between 3 and 4. And is it going to be closer to 3 or closer to 4? It's going to be closer to 3 because 10 is close to 9. Okay, so that's kind of how you approximate. So I would call it like a negative, for my answer here, I'd call it like a -3.1 or something like that. It's going to be really close to that. So how do we mark that? Well, if we're at 0, we go -1, -2, -3, and then a little bit past it. So that right there could be my square root of 10. Okay, so that's it for week 1, guys. It's just practicing this stuff and making sure that you can put numbers together. The only thing I left out is like maybe if you wanted to do arithmetic, you know, like if it was 3 minus 6 or something like that. For 3 minus 6, I would put my finger on the number line. You're starting at a +3, and if you're taking away 6, you're going backwards 6. So you're not adding 6 this way, you're taking away 6. So 1, 2, 3, 4, 5, 6, and you would end up at -3. So you might already remember that from last year, but just in case, that would be how you could do something like this if I give it to you. All right, try those problems. Watch the video on the solutions, and then if you have a hard time, we'll talk about it in tutorials, and I'll make up some other stuff for you while you're there. Thank you, guys.